Good afternoon, everyone. Thank you for joining our Big Data Analytics webinar today. Just like to say thank you very much. Our presenters today are Serhiy, Haziyev and Olha Hrytsay. Before we start, just wanted to say if you have any questions, then please email the address at the bottom of each screen, and then when we get to the end, we'll answer as many questions as we can. And if you could please keep your audio on mute so that we don't have any background noise, it would be much appreciated. I'll just pass over to Serhiy.
Hello, let us briefly introduce ourselves. My name is Serhiy Haziyev. I'm Director of Architecture at SoftServe. My professional background is about 15 years in designing and developing enterprise-grade solutions. Currently, I lead an architecture team with more than 40 architects with versatile skill set in technologies and industry verticals. And my colleague is Olha.
Yes, hello everyone. So my name is Olha Hrytsay. I work at SoftServe as a data architect and BI data warehouse consultant. I have more than 7 years of experience in building business intelligence, data warehousing and big data solutions. And I'm leading the BI Center of Excellence and Big Data Competence Group in Software Architecture Office.
All right, and a few words about our company. Our company called SoftServe, and if you are familiar, by the way, with ice cream SoftServe, it is not about us. At the same time, we provide soft and sweet service in big data, if you will. And few facts about SoftServe. SoftServe was established more than 20 years ago. Currently, it consists of more than 3,000 employees across US and Eastern Europe. The company successfully finished thousands of projects for clients, including the highlighted here, such as Cisco, HP, IBM, and many others. In this presentation, we would like to address big data analytics challenges when you cannot completely rely on traditional methods and technology. The new technologies such as MPP, NoSQL, and Hadoop require skills and experience that might not be available in-house. You may have ideas, but facing a lack of expertise. And at the same time, other companies may offer competence and services to help customers bring their ideas into life. We will provide overview of product development lifecycle and explore how collaboration with partners can help innovate and significantly reduce time to market. Then discover challenges of traditional analytics architecture and how modern architectures help to deliver big data products. And we will illustrate it with real-life project case studies. And at the end, we will provide practical tips on how to properly start a big data analytics project with software development partner to avoid any unpleasant pitfalls.
Okay, so let's start with any successful idea that can be implemented using big data. So big data world is growing very rapidly. There are a lot of big data startups. They are hot, and investors are looking for very promising startups and are betting on them. During 2013, a lot of investments were done, up to $4 billion, which is almost the same as during previous 4 years. And also a lot of acquisitions were done. Gartner even predicts that till 2016, big data will drive more than $200 billion in IT spending. So what are the top startups which received the most funding? Among them, there are a lot of technology or product-oriented companies, for example, like MongoDB, Cloudera, Hortonworks, and service or solution-oriented companies like Palantir, New Sigma, Good Data. However, big data is rapidly developing not only as startups, but as additional direction to the main business. There are two good case studies demonstrating how companies can get extra value to their core business from utilizing big data. For example, Heineken using sensors analyze shoppers' behavior in front of the shelf, and they generate metrics and real-time events, which actually help them to drive more conversion. So currently they are doing a pilot project in one Argentina store. So they actually analyze what influence on the consumer's selection of the particular bottle, and in addition to vast amount of data that they are collecting, like weather forecast or sales data, and they analyze this user behavior data as well. And in general, they are able to understand their customers better, and as a result, offer exactly the product that they are looking for a certain moment in a time and in place. Another good case is Spotify. So this is a commercial music streaming service. It was launched in 2008. I would say that they are by themselves a big data solution, because currently they have more than 24 million of users with 24 petabytes of data, and it is the biggest Hadoop deployment in Europe. It's more than 700 nodes in Hadoop clusters. And so in addition to their main business, like music streaming, creating custom playlists, doing some recommendation, they're doing some funny things like last year, based on the users' behavior data that they collect and analyze, they predicted the Grammy Awards winners. Big data introduces a lot of challenges. So in general, big data is generated by everything, and it's everywhere. Every digital process, social media, sensors, mobile devices produces. So there are a lot of diverse data sources which were not so intensively used previously. Big data has become, I would say, too complex and too dynamic to be able to process, manage, and store it with traditional data tools. And to extract a meaningful value from it, you need optimal processing power, new skills, new architectural approaches. And there are four main big data challenges: variety, velocity, volume, and complexity, which are the main drivers for the solution architecture. So as you can see, that depending on the nature of big data source, these four challenges can be represented differently. And this defines the way how you should work with them and how complex your solution is going to be. For example, the more unstructured data is, the more complex is it processes and make analytics on top of it. Big data analytics introduces new ways for data analysis. In comparison to traditional BI, big data analytics shifted the focus from the questions like what happened and why did it happen, to discovery of unique insights, formulating new hypotheses, asking new questions like what will happen. With big data analytics, data scientists and others can analyze huge volumes of data, also raw data and more types of data that conventional analytics and business intelligence solutions can touch. As a result, using high-performance data mining, predictive analytics, text mining, forecasting, and optimizations on big data enables us to uncover hidden patterns, unknown correlations, or other useful information that can be used for better decision making, for making a data-driven decision, and to drive innovations. So you might be, I would say, an ISV company or enterprise company who develops software for internal needs, and one day you may have a brilliant idea to build your big data analytics solution. How typically this process looks like? Everyone starts from general and goes to concrete, and then back from concrete to general. So you are definitely starting from research and development. You analyze the market, its needs. You're trying to collect all possible information to guess the trends. Then you narrow the research, create conceptions, build prototypes, test hypotheses. You define the success criteria, and they make measurements based on the success indicators. After that, you analyze the results, and you go from the concrete to general. You evaluate the possibility to extend this pilot to a product or solution, You consider what is worth doing and what is not worth doing. You define the product scope, estimate time to market, request budget, and start the implementation, and all other activities that are needed. Some companies are trying to go through the whole cycle by themselves and do innovation in-house. But some do a lot of innovation out-house. For example, due to lack of in-house expertise in some areas. And they're using an open innovation or collaborative innovation. We are involving partners. Usually company goes with a combination like 30, 30, and 30. 30% they keep in-house, another 30% they outsource in nearshore, and the rest 30% they outsource in the offshore. On this slide you can see the areas that our company is covering. So, and due to a lot of projects that our company is working on, it helped us to collect knowledge and as a result create a set of reference architectures, patterns, best practices, and so on.
If we take a look at big data analytics use cases, we can distinguish at least 3 generic cases or business patterns, if you will. Let's start with data discovery. Data discovery is when data is being collected and used for further exploration. Often this is called as a data lake. The case is pretty common in multiple industries, from retail to healthcare. The motto here is, let's store first and then find something useful. It might be a correlation between customer behavior and sold goods, for example, or correlation between a patient's DNA and drugs effectiveness. Typical users in this case are data scientists or data analysts, and typical challenges are how to store more data and how to improve performance of data scientist teamwork or performance of their queries in particular. Another use case is real-time intelligence. This is a case where decisions must be triggered instantly based on historical data and actual situation. For example, recommender engine, trading, or fraud detection are just some samples of such systems. Typical users are consumers and automated algorithms, also called as intelligent agents. Often data discovery results in creation of a predictive analytics model, which is a basis for real-time intelligence. So the typical challenges here, achieving low latency in milliseconds or seconds, and strong reliability. And the third case, business reporting, is where big data is being refined to fit classic BI reporting systems. The challenges are more traditional, such as keeping good quality of data and providing self-service for data users. For example, ad hoc reports for business users or personalized dashboards. The highlighted challenges, as well as other, such as security, extensibility, form a list of architecture drivers. And when implementing a number of big data analytics projects, we noticed a great commonality that leads to similar technical solutions. For the sake of simplicity, we divided them to 3 architecture groups. Extended relational, which is based on relational principles and SQL. Non-relational, NoSQL based, as well as built with Hadoop or search engines. Hybrid is a mix of relational, non-relational, and other techniques. All 3 architectures have own pros and cons. Some better fit for processing unstructured data, and some better fit for ad hoc analysis, for example. And we need to realize that there is no silver bullet nowadays. There are multiple approaches that could be the best option, but under certain conditions. And the goal of reference architecture is to be a tool to discover that optimal solution, optimal option. Here is a high-level view of a traditional data analytics architecture. The data flow starts from left to right. the three layers in the middle are core layers of data analytics solutions that include components such as ETL, data warehouse, and query and reporting system. The problem is that some of these components become bottlenecks in a big data solution. This is especially true regarding data warehouse, data mart, and lab cubes that are based on RDBMS and SQL philosophy, which counts almost 30 years. Nobody could imagine at that time a petabyte scale challenge. And at the same time, RDBMS vendors are extending their technologies, so it makes possible to store and process hundreds of terabytes, or in some cases more than a petabyte. There are several techniques to achieve such scalability that might be already familiar to you. MPP, which stands for Massively Parallel Processing, is a clustering technique to store and process data across multiple servers. Teradata, IBM Netezza, Microsoft Parallel Data Warehouse, HP Vertica, Amazon Redshift, just a few vendors' names that provide this technology. Column-oriented architecture, it offers better query performance and data compression when storing columns as separate files rather than in row-oriented fashion. In-memory analytics, that's much more flexible than lab cubes, such as Tableau, ClickView. It doesn't mean, however, that these technologies automatically solve all big data cases. For example, processing unstructured data obviously is not their strong side. So what is bad luck for one is good luck for another, and this is where non-relational techniques are really strong. Storing and processing large amount of semi-structured and unstructured data, such as server logs, social text, machine data, video pictures, and so on. The key elements in this architecture are NoSQL databases such as HBase, Cassandra, or MongoDB, distributed file systems. A great example is Hadoop HDFS, which is with MapReduce and Hadoop ecosystem creates an entire world for big data analytics. The next group is search engines like Elasticsearch, Solr, Splunk. It is important to understand that different analytics scenarios engage multiple alternatives, and sometimes it's not so easy to trade off. And when reaching limitations of a single architecture style, it's absolutely logical to combine different architectures, making a hybrid to cover the full range of requirements. Here we can see a table that summarizes a trade-off between extended relational and non-relational architectures. As you may notice, non-relational has advantages in large data volume support. Hadoop cluster can store and process tens of petabytes, while MPP data warehouse effectiveness currently ends close to a petabyte or hundreds of terabytes. Processing raw unstructured data and high data model extensibility, NoSQL schema-less nature allows extending data model on the fly. And low cost, Hadoop and NoSQL databases offer zero or low license fee thanks to open source. Another factor that hardware can be inexpensive too. So extended relational in its turn is strong in ad hoc reporting. There is a variety of mature SQL BI tools at the market. High data quality and consistency due to relational nature of storages, and better extensive security since RDBMS technologies are used in enterprise for many years. And last but not least, skills availability. When extended relational skills are still based on RDBMS and SQL, non-relational technologies require new skills which are not widely present on the IT labor market. And once again, just another view on the trade-off. Choose what you think is more appropriate for your purposes. Let's get back to business use cases we described a few minutes ago and explore how the reference architectures can be used to represent some typical solutions. Here's a sample of data discovery implemented using non-relational architecture. As you may notice, all types of data are stored at distributed file system and analyzed with help of MapReduce jobs. The concept can be easily mapped to Hadoop ecosystem stack, where Scoop is responsible for retrieving data from structured sources such as OLTP, Flume for streaming semi-structured messages in XML or JSON, and Hadoop API can be used for the REST data sources, including unstructured one. HDFS is used as a storage in Hive as a query engine, or Impala, for example, from Cloudera. So in such a way, data analysts and data scientists have a data platform to find useful patterns and correlations between data from multiple sources. And case study.
Yeah, and we have a case study that reflects this big data analytics use case. And so this case study is related to retail vertical. This is a large e-commerce platform. The idea was to build an in-house analytic platform for ROI measurement and for performance analysis of every product and feature delivered by the platform. So the platform should provide ability to understand how end users are interacting with the service content, with products and features on the site. Also do a clickstream analysis and perform an A/B testing. So this is not a Google Analytics-like platform because it's oriented on collecting more granular data and more specific data, and using it not only for marketing, for improvement of the marketing strategies, but also for analyzing of users' behavior, for defining the user behavior patterns, providing some recommendations for users in order to improve sales. And another usage of the platform, a big data scientist team is using it in addition to all other internal data sources. So in this slide, you can see actually the steps of the product development life cycle that was covered by our company, and it includes the implementation of the solution itself and also maintenance and support, some DevOps activities, and going to the next phases like developing new features of the product, new versions of the product. So in this case study, volume, data throughput, and extensibility and self-service, they were the most significant architecture drivers in the solution. So currently the solution stores around 45 terabytes of data, and it is expected to store more than 100 terabytes in the nearest future. So scalability is really very important. And since there are millions of end users which use the platform, data throughput is very high, more than 20K per second. Also extensibility, I would say data model extensibility was important because platform is growing, new features, products are being added, and the more custom tags appear. So the architecture and solutions should be extensible enough to handle this. And if you talk about the self-service, we ad hoc reporting, so it was not critical in this particular case, since the platform is mainly used for internal needs, and all reporting capabilities were presented mostly via canned reports or predefined reports. However, there was a big stress on data discovery scenario. Data scientist team had to be working with the data, identify some patterns in user behavior, create some complex predictive data models. So based on a trade-off that was performed, all architecture drivers were analyzed, and as a result, a non-relational architecture was a better choice in this case. First of all, because of ability to highly scale and build an extensible solution, we are using a NoSQL data store. And although NoSQL is not so effective in creating data marts for ad hoc reporting, common families DBs such as HBase allow creating materialized views for candidate reports from large data sets. So reporting capabilities were implemented via using materialized view pattern. So in this slide, you can see the high-level architecture of the solution. So the platform itself is hosted on Amazon. This was actually one of the architectural constraints. All the granular data is stored in Hadoop HDFS, and the aggregated views oriented for the reporting needs are stored in HBase cluster. Some custom scripts are responsible for transferring data from S3 to HDFS, and scheduled MapReduce jobs are responsible for processing the raw data and storing it in the schemas on HBase, which are optimized for reporting. And the data visualization is implemented using custom API and UI layers.
Mm-hmm. So it was a sample of data discovery business pattern, and let's take a look at next demonstration of building business reporting solution with large data sets. So here is an architecture sample that reminds traditional, but as you may notice, instead of conventional ETL, here is a messaging integration pattern. The reason to add flexibility into a semi-structured message parsing using script language such as Python, for example, and reduce latency. Data warehouse, which is based on MPP, can handle tens of terabytes rather than 3-5 terabytes as a traditional RDBMS system. But at the same time, reporting engine can be SQL-like, so it is possible to leverage existing relational skills when designing and implementing such a system. Let's map to technologies, and the current picture represents Amazon stack, but at the same time it is possible to use any other vendor that provides described building block, for example, Microsoft or IBM. Let's switch to a project case study to illustrate the trade-off between relational and non-relational in real life for business reporting solution. The project is about a reporting solution for cloud-based platform for developing mobile applications. The reporting solution is used to track usage and bill customers based on pay-as-you-go model. And here is SoftServe involvement into product development lifecycle. As you can see, we started with feasibility study, provided output to the customer, and customer used this for strategizing and for further business analysis. Then we continued with proof of concept, prototyping, final design, and then implementation, pilot production, and continued with maintenance, with extension, and then continuing with further versions of this product. The architectural decisions which were made at this project were driven by extensibility, ability to analyze custom metrics which are unique per customer. So this is clear multi-tenant solution. Data quality, which should be high enough to fit billing engine, and self-service includes ad hoc reporting, the ability to build custom reports based on the custom metrics. The trade-off between extended relational and non-relational architectures shows that relational approach wins for two architecture drivers, as you can see in this little table: data quality and self-service. At the same time, we have something to do with extensibility, provisioning custom metrics in runtime. The workaround is to use pre-allocated fields pattern or reserved columns which are mapped to customer-specific metrics. The number of possible metrics in this project was not too high, up to 50, what is important that column-oriented architecture allows keeping much more columns than traditional row-oriented techniques without significant performance degradation. And for traditional approach, even 50 custom metrics and custom fields could significantly slow down performance. And here is a high-level view on the reporting solution. So the technologies are Amazon Redshift, used as a data warehouse, Amazon SQS, S3, and Python are used for collecting messages from millions of mobile devices, and Jaspersoft BI server is used for reporting capabilities. And now let's have a look at possible implementation of real-time intelligence solution. So this is a kind of hybrid architecture called Lambda architecture, which is perfectly described by Nathan Martz in his recently published book, Big Data. Nathan is the creator of Twitter Storm, a complex event processor. So the Lambda architecture aims to enable real-time operational and historical analytics with a quite elegant solution. While historical data is processed with a batch layer on an hourly or daily basis, the real-time data is streaming through speed layer in milliseconds or seconds. Technically, the batch layer can be implemented with Hadoop HDFS, MapReduce, Hive, or Impala can be used to populate batch views, which are implemented with HBase or other NoSQL databases. And talking about speed layer, it can be implemented with Storm or other complex event processing engine like Amazon Kinesis. Or if you don't need any complex real-time computations, you may use Flume, for example, and in-memory database for static reports. And at the end of our presentation is a short quintessence, if you will, recommendations how to improve chances to successfully deliver your great ideas. So first, understand your in-house big data capabilities. Do you have required skills or do you have enough resources? This will help to determine what steps from product development life cycles can be done with partners. Establish collaboration approach and agree with your development or consulting partner on a level of ownership for each step in the product development life cycle. If your idea is bright new and there are hidden technical risks, do feasibility study with less data to make sure it works as expected or it's feasible to implement at all. Select appropriate reference architecture and map it to technology stack. Such technology agnostic design should help you to avoid vendor lock-in. Prototype and re-evaluate the architecture. Since technologies are new and their stability require validation. Estimate implementation hours. This will help you to stay within a budget or revise scope at least. Align project milestones and success criteria with your partner. This should give transparency and avoid any miscommunication before project execution. And set up DevOps practices from the very beginning to establish continuous delivery. This will save a lot of efforts and minimize risks when rolling out to production.
Yeah, and about DevOps, I would like to add that it's really very important to establish the practices from the very beginning, because we know such cases for one of our clients, that when practices were not established from the very beginning, and the project was really a huge project with a big investment, and when the solution was implemented, as a result, it failed because of inability to deploy it on the production environment. And the main reason was because DevOps was not taken into account from the very beginning. And not only for big data projects it's important, but also for others as well.
Yeah, absolutely right. And advance in solution development through small wins. Do short iterations, get feedback, and make corrections in your roadmap. And be ready for changes. Big data technologies are evolving rapidly. At some point, you may find that you use legacy Hadoop.
Yeah, it's definitely very important, small wins, because in December we were working with Elasticsearch. It was one version, and now it's already produced. They released another version of Elasticsearch. It has a lot of new features, a lot of new good functionality. So it's really very important in big data solutions to do short iterations, to have a small wins, because so you may notice that in some periods of time a lot of better solutions are already in the market, and so you can save some costs, and you can omit some risks if you just do a short iterations.
Right. So I believe we have some questions.
Some time for questions.
Yeah.
Okay. So as I can see, so the first question, that is, are there any other reference architectures you describe technology agnostic?
Yeah, absolutely. So consider these architectures as building blocks. So every block has its own place and has some requirements for technology. So with every block we have associated a couple of technologies, and of course new technologies are coming, and we are continuously evaluating them to find proper place in these architectures. And what is a major advantage of having such reference architectures as your toolkit, if you like, is to have better predictability in design, to avoid early risks associated that some technology do not fit well with another technology, and you have at least a blueprint to start with something substantial, not just from blank page.
Yeah, definitely. So I see that we have one more question, and it is, what business cases can be covered by Lambda architecture? I would say that's a very good question.
Yeah, absolutely good question. And if we have a look at the use cases we described, data discovery, yeah, absolutely. So Lambda architecture batch layer, this is especially designed for data discovery because it collects all the historical data, right?
Yeah, and I would add from business perspective, for example, that one of the projects our company is working is that fits to Lambda architecture very well. This is a log analysis project, so it means not only log analysis but monitoring as well. So we have like two layers. One is for batch, when just collect all logs and store in centralized storage for defining some trends and analyzing the performance of the servers from which the logs are collected. And we have a speed layer there for analyzing the streaming data. For example, there's some system metrics, how CPU is used, how RAM is used, and also we have a lot of rules defined on the streaming layer so that appropriate actions can happen if appropriate triggers can be triggered if some faults are done or something like that. And also, as I remember, we have another project in healthcare when we have Lambda architecture.
Yeah, absolutely. And this is real-time intelligence use case. So we already identified that data discovery and real-time intelligence fits absolutely well into Lambda architecture. And business reporting, by the way, it is possible to put a relational data warehouse which will serve as a data mart for business reports.
So I would say in general that Lambda architecture is now widely used. So even so the companies can use this type of architecture and may not call it Lambda, but we have noticed that some companies were using it, but they didn't know that it's this type of architecture.
So
Lambda,
the word is quite new, but it describes solutions that might be already in place.
So I see that one more question is coming is here. So from your company experience, what data sources are mostly used in big data solutions? I will answer this question. So I can say that in general, majority of the projects use some log data for analysis. So it's web server logs, some for doing some clickstream analysis. So this is also a machine-generated data that is collected from some sensors. For example, one of the projects that we have is collecting data generated by IPS devices, including prevention systems. And so I would say that this is mostly used sources in big data solutions that we have at SoftServe.
And as well as social networks.
Social networks. This is becoming more and more popular to use social networks to do some sentimental analysis and to actually get an extra value from it. So we have I might say that we have two good cases with social data, like when data from social networks is analyzed in order to see how marketing campaigns are done, in order to see how companies can improve sales and so on. So this is actually a dedicated solution for analyzing social media. And another case with another project that we have is when this is scoring for banking, and in order to make more precise scoring and see if the client is trustworthy, also some social networks, social media data is analyzed in order to see client behaviors, patterns, to see some habits and so on, and to see to make the score more precise. So this is social media are also very used right now in different areas. So I see no questions, no new questions. Okay.
All right. So thank you for your attention, and we wish you good luck in your exciting big data journey.
And so all the materials will be available, and audio recording and the video recording will be available after the webinar, and also the printed PDF version of the presentation. So thank you, everyone.
Thank you.